Welcome to Cpp.chat, the most well-tested podcast for C++ developers by C++ developers. Before we get started, I'd like my fellow host John to read this week's disclaimer.
Thank you, Phil. All right, this week's disclaimer. Information presented on this episode is considered public information unless otherwise noted and may be distributed or copied. However, attribution is requested as defined in the Creative Commons Attribute Share Alike 3.0 Unported License. Cpp.chat does not claim to be an authority in the field of software testing, and the use of any information on this site is at the owner's own risk. If your software crashes, or if your project fails, or you do not succeed because of following any of our guidelines, Cpp.chat will not be held responsible. On the other hand, if your software excels, or your project succeeds, or if you get promoted because of following any of our guidelines, Cpp.chat should be acknowledged when you receive your accolades. Thank you. So, how are we doing, Phil?
Doing okay here, thank you. Yes.
Excellent. All right, we have a couple of guests who have not been on before. One of them is Martin Hořeňovský. I hope I got that close. He's joining us from Prague, and he's been collaborating with Phil on Catch. Martin, does Phil torture you with puns the way he does me?
No, usually he doesn't.
He doesn't.
Oh, okay.
I am so disappointed.
I'll do it a different way.
He does it a different way. All right. Okay. So how long have you been working on Catch?
It's a year and a half now.
Year and a half, right? And we were just establishing that Catch is about 8 years old, or 8 or 9 years old, something like that.
I actually don't know. You have to ask Phil.
I think it's going to be 8 years old in December.
I see. Okay. All right.
I actually pushed out the first release while my wife was in hospital with our newborn twins, so I know the exact date.
Okay.
Outside of visiting time.
I was going to say you might not want to mention to your wife that that's how you keep track, but okay. Also joining us for the first time in the show is Kevlin Henney, who, while on the standards committee, proposed long care instead of wide care T. For this, Kevlin is my idol, and I am starstruck to have him on the show. If you've not heard Kevlin give a formal presentation, you really missed out. Unfortunately, Kevlin has never spoken at C++ Now or CPPCon. What do I have to do to get you to show up at a conference?
I'm open for bribery and all kinds of things that seem to be coming back into fashion these days. It's a question of calendrical alignment, and mine is very poor at the moment. I really have tried to make an effort this year, and we kind of came close, but that didn't work out. And, we talked about
doing a class, actually.
Yeah, that's right. And I'm actually in the US at the time, so it's. But yes, unfortunately, that's not going to work out. We were discussing. I was actually at C++ Now before it was C++ Now, so I guess BoostCon is C++ then by definition. But I was at the first BoostCon, and for anybody who is on the Slack channel and is wondering about the story, it was the travel story of me getting there and turning up 30 minutes before the end of the workshop, the full-day workshop I was supposed to be delivering with Jeff Garland. So I came in and quietly sat at the back before Jeff noticed that I had actually turned up, having dumped him with the hardest chapters and material in the morning. But yeah, it was a hell of a travel story. So I have been there in the rarefied atmosphere of Aspen, and I'm sure I will return. But again, it's a matter of timing. But yeah, it will happen. But no, these days I want to become a maintainer of Catch now that I've discovered that Martin doesn't get tortured by puns. I think that's because everybody else gets tortured by puns, and they are not maintainers of Catch. So therefore, I'm going to use some fairly not exactly robust logic to deduce that to escape the puns, you need to become a Catch maintainer.
What a great way of recruiting for an open source project.
Exactly. Yeah, that's right.
Yeah. So I have to change my policy on that.
You are an evil genius. So we were actually talking about the roots of Catch. Is that where we want to start? Oh, we should actually, we have a couple of announcements. let's get those out of the way so we can talk about catch and testing, right? Pacific Plus tickets are open. CPPCon tickets are open. The schedule is up. Did we do anything special for CPPCon? Oh, well, there's a couple of interesting things being cooked, but we can't talk about those yet. Meeting C++, tickets are open, schedule release, and I think the schedule is up for Embed.
It is,
Embed
yes.
Day as well.
Yeah.
All right. And C++ on C, tickets are up. You're in the middle of reviews. Are you still soliciting reviewers?
Yes, because as I think we mentioned last week, I was overwhelmed by the response to the call for speakers. Had over 100 speaker submissions. Definitely going to need to expand my review team. So if anyone's interested in helping out with reviews, I have some for you. Please let me know.
So over 100 reviews is a huge number of reviews.
That's half the CPPCon, I believe.
Yeah, half that, as many as we would get at C++ Now. So there's incredible interest, at least by speakers, in the conference. It may turn out that only speakers show up. I don't know, but the speakers really want to be at the conference.
They have stuff to say.
They have stuff to say, and they want to say it on the White Cliffs of Dover. And let's see, also ADC, the Audio Developer Conference tickets are open. There were a couple of news announcements that I caught my eye this week. One is from Sar Raz, who announced that Clang Concepts is now feature complete. So you can either build the experimental version of Clang, or you can actually play with it on Godbolt and test out concept features. So those of you who are itching to do that, it's now available for you to play with.
Not just a concept anymore.
It's not just a concept anymore. That's right. And then in the library news, Google released something called Filament. And I saw someone from Google pointed out, okay, this isn't an official Google product, but Filament is actually a rendering engine. And I think its intention is Android, but it actually runs Android, Windows, Linux, and Mac OS. So it's in C. And check out the show notes and at least go to the follow the link, because even if you're not the least bit interested in the engine, you should look at some of the images that are rendered, because they're kind of striking. At least I was kind of impressed. So
yeah, I can definitely vouch for that. I had a look myself.
Yeah, pretty cool. So those are the news things that I think. Is there anything else we need to say before we dive in?
Only that you glossed over my biggest news of the week, which was
sorry.
that the ticket sales are open for C++ on C.
Yes.
But that's big news for me. It may not be for everyone, but anyone that's interested in going, you can now go and see.
I think the reason is I was thinking that they were open during the last meeting, but this is the first time they've been open. Okay. All right. Sorry. Yeah, absolutely big news. So if you can make it there in February, you're going to have a great program to pick from very clearly.
Yeah. So the early bird pricing will last until the speaker selections are made. So you'll be getting a reduced price without knowing who the speakers are going to be. But I can definitely tell you that we've got such a great lineup that it's not going to disappoint. I think it's going to be a safe bet.
Was that design intentional?
The lining, yes, yeah.
Yeah. Okay. All right. We did that at CPPCon as well. But the first year it wasn't really intentional. It was just kind of an accident. And then I realized, that's kind of interesting that we're giving a price break to people who are willing to take the conference on its faith, which was a bigger deal the first year because but
right.
now,
which is why I think it's worth mentioning that we don't have a track record, but we've got all the good speakers, I think.
You don't have a track record, but you got the promise of good record tracks. There you go. That's how you spell it, okay?
You've just disqualified yourself from maintaining catch.
You can't fund back, apparently.
Well, you set the entry bar low, but I went lower. Yeah.
So talking about that, that's a good segue actually, because
Sure.
in a very real sense, Kevlin was conceptually a maintainer of catch before there was a catch, because some of the core ideas of catch were actually stolen from Kevlin. One of his proof of concept projects. And I went to see one of his talks on it. We'll put a link to my write-up of it and a link to the video in the show notes. But maybe you want to tell us about that, Kevlin.
Yeah, it was the thing that the talk was rethinking unit testing in C++, and I did a kind of a version of it in January 2010. But the one where it all came together was actually the one that you saw, Phil. Was it was ACCU London Skills Matter in May 2010. And it's a talk I did without slides because I wanted to use code and just sort of put up bullet points on an editor. But it was one based on the kind of the typical way that many C++ developers might go about it. And having both taught unit testing in a variety of languages, but also then seen it in practice and mispractice. I mean, people have so many different interpretations of how to go about this, but it also turns out people have many different habits that they cling to. And there are certainly a lot of thinking habits in the C++ world that sort of I noticed was slightly different to other languages. And I was frustrated because I kept thinking, well, the C++ testing landscape does not seem to be very rich. It's sort of a lot of people are doing the JUnit hand-me-downs, and JUnit itself is a hand-me-down from Smalltalk. So the S-unit hand-me-down. So JUnit's the not quite right version of a Smalltalk unit testing framework, which was actually better, from what I can tell. And it kind of gets borrowed down, and you end up with something. By the time it got into C++, you got stuff like Cpp.unit, but also things that were similarly inspired, even if they didn't share the genetics of it. And they weren't very expressive. They didn't feel very idiomatic. They looked like a bad port of Java. In other words, missing out all the features that would allow you to do a good job in Java, such as reflection, missing all of those out. And you ended up with this meager subset that wasn't really idiomatic C++, and it wasn't really idiomatic Java. It wasn't idiomatic anything. And when you came to express your tests, then people had a very constrained way of thinking about it. And they would end up with very short test names, just thinking of them as just ordinary identifiers, and not a very expressive assertion vocabulary. And although we did have boost test kicking around at the time, again, that one had a particular philosophy that was very what I would call flat. In other words, it's based on functions, which is much more idiomatic. But the way that I think about tests is much more nested. It's the idea that you group tests together, and you want that grouping to be a first-class citizen. It may not be a class, but it may be something else. But I'd also noticed that when I was teaching, if I told people, if I used the word function and got people thinking in terms of function, they would normally revert to function naming habits. But if you told them this is a name, write it out in English, and then throw the underscores in later, think of it like that, it started shifting them to a much more expressive space. And I thought, well, the most expressive space you can have is strings. And I'd seen this in a number of other testing frameworks, particularly some of the BDD frameworks that were popping up in the late noughties. And I thought, I wonder if there's a way of doing this. And I prototyped something in JavaScript. Can I say JavaScript on this show without getting thrown off for swearing? I don't know. You know?
Please you're out.
Yeah, so hey, that language, yeah, so what am I talking about JavaScript? We're talking about programming here. So anyway, I did it in JavaScript. I came up with an approach, a lightweight approach in JavaScript. It was very descriptive, and I thought, I wonder if I can do this in C++. And it took a little bit of kicking the language, and eventually realized that if we just said, what do I want it to look like, before we started saying, oh, I've got functions and classes, where do we start? And that idea of creating nested structures, so then the challenge was nested structures that have string descriptors rather than identifiers or anything like that. Let's think a little bit outside the block. And it was a case of like, how do I make this work? And so that was the basis for that. And the basis for that was dreamed that up on the approach path to Heathrow. On a return flight to the UK.
I knew we'd get a travel story in here.
Yeah, I was going to get a travel story in there. And then driving home from Heathrow, I live in Bristol, so that's a decent drive. I worked out most of the rest of the details, which is why the original testing framework was called LHR, Heathrow. Because I like airport codes. So, and it seemed a suitable, three character identifier that nobody else was really using. So that was the basis of that. And I just wanted in that talk to kind of explore the different ways that people did this. What about just a bunch of assertions? What about functions? What about functions with a little bit of macro help to auto-register? And I wanted to build this one up. And there are a couple of other things I threw in there as well. But I sort of said, and how do I... these are looking from the language upwards, but how do I go at it from another point of view? And so then you emailed me, Phil, after that, asking for the code. And as it's a proof of concept, I had just go with it. See what you can do with it. I gave it out to a few people I know, a company that were using it internally, and but really, my job there was done. You did all the hard work. It was I did the thinking bits, the abstract bit. You did the concrete bit. But it was that idea of I wanted to get as expressive as possible, and I wanted the other aim was to try and reduce assertion vocabulary, because we end up anybody who ends up using almost any testing framework ends up having to learn a family of assertions, and they have to learn the little quirks of the assertion frameworks, and is this how is this one spelt? Is it? And I just thought, couldn't I at least reduce it mostly to one assert? And given that most asserts for equality, then what about doing something like a capture using a ridiculously high precedence operator to pull that out and then reconstruct the actual expression at runtime? So that was a bit of fun, just trying to explore that. But yeah, that was the origin story of that one. And I've since messed about with a couple of other kind of frameworks, and they've ended up with airport codes as well. I think that might be a thing, but I can't use Stansted because that's STD. But I have used Gatwick LGW, and I'm currently on London City Airport LCY. So yeah.
Have you been following the evolution of catch? Do you think it catches? If I can throw my own pun in.
No, that's not even close to Phil standard. That's not even close. I'm sorry, John. You have to try harder than that. Have I been following it?
I try.
Try and catch. There's something in there, I have been. On and off. Every now and then I dip in and out. And catch 2 is kind of. Can we do this without any? I was about to say, it caught my attention. Can we do this without any catch-related puns? I don't think it's actually possible. That's why you chose it, Phil, isn't it? Yeah. It's not just the language; it's the English as well. So I've been following it on and off, and I every now and then there's something that kind of pulls me in. So, for example, when Phil added the constructs to support a more BDD-friendly style for some people who are coming in from BDD frameworks. Having basically sort of a scenario given when then, that makes it feel very familiar.
What's BDD?
Behavior driven development. Depending on who you talk to, BDD is either TDD or it is really a way of a bigger picture that takes you into unit testing, but also starts from the outside. And requirement space as well. So a much deeper slice through that.
Starting with use cases, is that what you're saying? Starting back.
Yeah. Basically, user stories and the same structure. There's this curious thing that we keep finding. There's this kind of rule of 3, this 3-act play structure to a lot of test cases. And in classic TDD, people often refer to it as arrange, act, assert. Arrange. Set up your state, arrange the objects of interest, do the action that you really want to focus on in this test. So everything else is set up, then the action of interest, and then you assert. So you got the 3 A's. So a lot of people call it 3 A's. Dan North, when he set up BDD, back sort of circa 2003, 2004, his motivation for doing so was slightly to get away from the idea of testing as kicking a thing, does it work? And trying to be more expressive, focus on the behavior. And he wanted to shift from conventional testing terminology. So hence he spoke of behaviors rather than tests, specifications instead of suites. And he shifted the vocabulary so it got you thinking about what is this thing, whether it be an object or a software system as a whole. What is this thing? What do I want from it? What behavior would I like from it? Whereas I think as developers, we often think from the inside out. It's just like, okay, I can see how I'm going to implement this. I've got the algorithm, I've got the representation, and that is half the truth. But the challenge is somebody's going to use this. Somebody needs to reason about it. What does it look like from the outside? And so very much anchoring his perspective in that. So BDD has it clearly has an overlap with the TDD world and the unit testing world, but sometimes people think of it in terms of acceptance test-driven testing, much more bigger picture user stories and so on. But I regard it as a continuum, and it was exactly that kind of thinking that I think is comfortable when people sort of see the given when then and realize it's isomorphic with arrange, act, assert, and actually it fits with the classic Tony Hoare triple of precondition, action, postcondition. Here is the thing as we set it up, here is a thing of interest, and here is what we're expecting or requiring afterwards. There's a kind of, it's the same structure, and I found that's a very comfortable way of leading people into that thinking. How do we, rather than I'm trying to poke my code to see if it works, that doesn't necessarily give you a maintainable test. Whereas if I give you a narrative, then that works very well, and then that people find that easier to access. So it's a question of communication.
So I think I kind of misdirected you by throwing that question at you, but we were talking about.
Sorry, I was supposed to say Catch 2. Yes, and I also saw Phil's excellent suggestion, excellent presentation on Catch 2 at Meetings Up at C++ just before Christmas. Yes.
All right. I think that, I mean, one of the observations I have is that this testing revolution that you've been talking about, getting people to think about test-driven development and BDD, I think that this is the situation where the legacy and history of C++ is what hurts us, because if you were inventing a new language today, you're creating your own new language. It wouldn't really matter what it is, whether it's an interactive scripting language or a new way of doing systems programming. But if you were doing it today, all your demos of the language, all your tutorials, everything would revolve around good testing practice. And in fact, it's likely there would be features in the language to support good testing. And C++ just predates our recognition, which is silly. You would think that we would have caught on to this very, very early, but it predates this, and so we don't have a culture in C++. Tests first, designing for testability, these kinds of things, and I think that's much to our detriment. As I said, if you were any modern language, any language that's, I shouldn't say modern language. I think C++ is a modern language, but it's not a new language. And I think a new language today, anyone talking about presenting, how do I use this language? How do I do anything in this language? The tutorials, and even, the language itself as it's delivered to you. When you install it, the first thing you're going to do is run a bunch of test suites and things like that. We just don't have that ethos. And I confess to this. I remember way back when I was a working engineer, trying to force myself to think about, well, maybe let's do a test first kind of approach. And even when I bought into that, I failed a few times because it was such an alien approach to the way we did things. Yeah. And I think it wasn't because anybody pushed back or anybody disagreed. It was just, it wasn't the culture.
It's culture. I think culture really is, for me, that was one of the recognitions, moving from one language to another, and one language culture, one conference to another. You start seeing it's cultural. There is that notion. I remember, let's jump in a time machine, go back to 2005, C++ Connections as in Las Vegas. And there are a couple of things there I thought were interesting. One, I did a session on TDD there. I don't know, I had 30, 35 people in the room. And I said, who here writes unit tests for their code? 2 people put their hands up. I was one of them. John Lakos was the other. And he's writing he's been writing the book for a very long time. But the point is that
I think you can pre-order it on Amazon now.
But the point is that that was it. That was the 2 guys in the room who were doing this, and there was no lack of intelligence or experience in the room. It's a cultural thing, and therefore, cultures have inertia. They have a depth to them, which is one of the reasons we like them, but they also have an inertia. And that was a very, very strange problem. But when we look back at the history of these things, it's slightly surprising that some things didn't take. So, for example, people often associate refactoring, which is, in the recent years is starting to make an inroad, proper, sensible inroads into C++ world. But people often associate it with Java. But the original refactoring work was done by Bill Opdyke in 1990 on C++. That was the origin story of that. And some of the best testing advice I ever picked up was classic Unix books, C culture on testing, that somehow did not make it to the big time, as it were. And so there was a cultural disconnect. So I think we've been kind of slowly but surely getting there. And it used to be a case of like, well, what C++ testing frameworks are there? And there really wasn't anything that I felt like I wanted to recommend. There were a couple out there, but now we're in a situation where actually we're reasonably well spoiled for choice in C++, which is a nice situation. There's still a bit of catch up to go, but T-catch, you see, I did not even intentional. Well done, Phil. But there is a point there in terms of adoption. But it's now out there that these are names that you can throw around, and people won't look blankly at you when you start using testing framework names in C++. So, which is definitely very different to how it used to be.
And my question to you, referring to that 2005 talk that you gave. You mentioned there was only 2 of you in the room using unit tests. My assumption is that other people in the room weren't opposed to that. They just weren't used to it. They just weren't doing it. It's not like they were arguing back. I mean, when we talk about new ways of doing things like, virtual functions, right? There were people who argued about, oh, no, that indirection, that's going to kill your performance. How could you do that? And all that kind of stuff. But for testing, nobody ever argued back. It's just they didn't do it. It's not like anybody thinks it's a bad idea. It's just that you need to exercise those muscles. It needs to become part of the pattern. You need to buy into it.
Yeah, there are certainly people that will object at various times and won't regard it as being within their job role. Maybe it depends on their background. So I found that sometimes because we've got testers for that, and it's like, well, no, that's software test. That's your whole system. That's not the same as I have just crafted this API. I've just built these classes. The question I want to ask you is, do these work as intended? Not do they work as part of a larger system, but on their own, do these components, these elements of a system work? So some people will kind of push back against that, but mostly it was, as you say, it was practice and culture. And if you're surrounded by lots of people that are doing it, it becomes obviously a lot easier to do. You're swept along, and your questions become very different. It becomes not whether, but how, and how do we deal with this situation? As becomes a much more open question than necessarily a challenge. And so that is definitely, and as you say, newer languages, new APIs, people wouldn't think of presenting them without these things. And in fact, funnily enough, in 2005, there was a panel on, back in the old days when it was going to be C++ OX. There was a panel on what features would we like to see in the next standard. And I said that there were 4 that I regarded as architecturally fundamental. One of them was threads. I said you can't be a serious. It's 2005. How can we have a systems programming language that doesn't have a sensible opinion on how to do multi-threading? This is something we need to care about.
We don't have a sensible opinion on that today, but I won't go into that.
Maybe sensible was a standard opinion. Let us use that word instead. There's no standard and sensible can actually be worlds apart, I've discovered, but nonetheless, there is that. What we would now call modules, but are basically dynamic loading. How can I have a systems programming language that does not have an opinion about how I can create an architecture with dynamically loadable parts? I mean, surely that is fundamental to many modern architectures.
I don't think that that's even considered in modules. They're not even talking about that. They're just talking about making builds rational.
Yeah, well, I think it's got half a foot in the door. It's just getting the other half in the other foot.
I think it's in the other door. I think that's the problem.
It's got through the wrong door.
2 different doors. That's
garbage collection, because that one's always sure to strike a nerve with a lot of C++ developers. But as I was saying at the time, because that was around the time that Herb Sutter and others were working on C++ CLI at Microsoft. And for me, I sort of said, well, look, here you have a platform that has garbage collection. If C++ is supposed to be a systems programming language, why does it not have an opinion about garbage collection? In other words, if more and more systems more and more runtimes are going to have this as a feature, then we have to have some way of dealing with it or even taking advantage of it. And reflection was the other one. Again, a lot of open architectures are based on, hey, I've just loaded something, let's interrogate it. And this is the basis for testing frameworks. In fact, that was one of the examples I gave, was I said I have no problem writing test frameworks in any programming language except C and C++, which don't allow me to just dynamically pick up a piece of code and say, what have you got? And then execute it. Hey, you've got a bunch of functions all beginning with the word test. Brilliant, I can do something with that. Instead, we had to have some very clever macro tricks, and I'm always in two minds about teaching people clever macro tricks. So there was that, and that's the thing is, of those 4 features, what made it into C++11 was threading, and the garbage collection model is at best halfway there, but it's not really usable, and we're still not there with everything else. So basically the 2020s. C++ should hopefully become a full systems programming language again.
Well, I would argue that C++ does have an opinion on garbage collection, but I don't want to go down that path. So
let's save that path for another day, because I have no shortage of opinions on that one. But nonetheless, that may take us off into the darkness. But yeah,
I'm going to shift gears and ask Martin a question. Martin, first question is, do you not pay your light bill? But
it's getting late over here.
But I was going to ask you how you got in with all this test stuff, because you're more like the mathematical, provably correct crowd, right? How did you get involved with tests and specifically working on catch?
I was taking over our C++ course at the university, and I wanted to provide our students with more homeworks with automatic testing. So I needed some testing framework that would work well, which meant catch, basically. Because I can't have my students go and, they are starting with C++, and I can't just go and tell them, okay, here have boost test, compile it, figure out how to link it, and have fun. So I needed something simple.
So you found catch was a better candidate for that, but that's not a reason. There's a lot of things I use that doesn't make me a maintainer on that. How did you go from this is the best thing for my students to use to I'm going to help Phil make this happen?
Well, I found bugs, and I fixed them, and I opened a PR, and then nothing.
So it turns out that Phil has 2 recruitment tools. One is he promises no puns, and the other is he deliberately puts bugs in that are easy to fix to kind of catch people into the...
No, but really, basically, I thought catch has potential because I was using it, and unlike, say, CPP unit, it didn't suck. And I thought it's kind of sad that it doesn't have maintainer, or basically no one to update it and fix bugs and so on.
I have a very smart friend who actually has a product whose marketing slogan is "It doesn't suck." He sells an editor and says, "BB Edit, it doesn't suck." So "It doesn't suck" is actually a pretty strong recommendation.
But I think Martin's point was that he was raising these PRs, but they weren't getting accepted because at the time I was so completely overloaded that I just wasn't really acting as a viable maintainer alone on catch. It was just getting too big.
So have you turned most of that over to Martin, or you guys share the load, or how does that work out?
Technically, we share the load. In practice, Martin's doing most of the work at the moment. So I'm very grateful to him for that.
I am too, because that frees you up to do the show. So thank you, Martin.
Okay, I want the LTs now. Can you talk about the future? Is there a catch 3 on the horizon? Are there features you're just itching to add but require some architectural changes? What's the...
There is going to be a catch 3. Don't know when yet. Martin's just said he's going to go and fix the lights. There we go.
I thought he was going to go and finish off catch 3.
It's
just a small matter of programming.
Yeah, that's right.
Yeah, we're just talking about catch 3 starting. But it is coming. Don't know when, but we are saving up a long list of small breaking changes that we're sort of holding back until we can go to 3. So it's not really so much about big features. It's just about the version change.
Actually, I thought we aren't doing catch 3. We are doing catch 2 version 3.
That may be true. That's yet to be decided. Because the whole reason that we're calling it catch 2 is technically it's actually a name change, because so many people found the word catch very hard to Google for in the context of C++ and testing.
I see.
So catch 2 has actually helped that. So the theory is that maybe version 3 will actually be catch 2 version 3. So we stick with the name.
Right.
That may be too weird though. We're not sure yet.
I've been thinking of ways of marketing the library, and I'm overwhelmed with puns. Catch 2, give it a try. Catch 2 fever, catch it. I don't know. It just gets bad.
The talk I did at C++ Now a couple of years ago, it was on persistent hash trees, and I actually said in the introduction that it was on persistent hash trees, and I said in the introduction that you can say the word tree as tree or trie. It's TRIE, and I specifically choose to pronounce it tree so that I don't get known as being both the catch guy and the try guy. And then this year I did a talk at C++ Now on error handling and exceptions, and of course I'm back to try again, so I can't really escape it.
I was thinking as we were talking about the culture, that one of the things that Alex Stepanov told me about the proposal, the original proposal, which by the way, that's where the term the STL came from. That was the name that he gave his proposal. And it's always ambiguous because people are a little unclear what is part of the STL and what isn't part of the STL, because it's never formally defined anywhere. STL is just the name that he stuck on the proposal that he sent to the standards committee proposing his library, which is a little bit presumptuous because it wasn't yet accepted as a standard. And so to call it the standard library before the committee had even looked at it was a little presumptuous. But what he was telling me about it is he said, it was a big mistake, but it just never occurred to me. He said, I had a complete test suite to test the library, and I never even offered it to the committee. It never occurred to me to do that. And I think that maybe this is something we should maybe give more thought to is, when is an API complete? Is it complete when you define the API, complete when you've implemented it, or is it complete when it contains a test suite? Because would it have been appropriate to include the test suite in the standard itself, or to define what the STL means in terms of a suite of tests, or would that have been an unnecessary constraint, and it's better to define it not in terms of specific code, but in terms of the intent? It's define it only in language. Does that make sense? What I'm trying to say?
I was just editing, not the last episode, but the one before, because I'm a bit behind. And one thing that I noticed was that you, John, made a point about trying to work out at least as a thought experiment, the dollar value of the code base in your company. And knowing that we have Kevlin on today, I know he has a thought on that.
Oh,
Kevlin?
Dollar value of... No, elaborate more. Remind me.
Well, it's the whole idea of whether it's the code that actually has the value.
Yeah. I think the thing here is the code or the functionality. And there was a tweet that I always go back to from Kirk Pepperday, who's a Java performance specialist, who tweeted at me, I don't know, God, it must have been 9 years ago. And he said, code, functionality is an asset, code is a liability. And I found that very thought-provoking, because where it does raise the question, where is the value? And we often think of code, well, there are those who do not consider code to have value, and I've spent most of my career trying to convince them, yes, code has value. This is a good thing. You know, it's not just something you toss off and just sort of throw there. The quality of it does matter, the amount of it, your ability to understand it, all of these things matter. But Kirk's point of view was wonderfully provocative, because it's basically said, no, code is a liability. What people want is the functionality, whether they're downloading a product, whether they're downloading a framework, a piece of code, whether they're copying and pasting from something online. They don't actually want the code. What they want is the functionality that it gives them. People have a problem, they want it solved. People want some functionality, that's what they want. They may look at the code, they may find it educational or interesting, but that's not the primary thing. What they want is the functionality. And so this idea is that's what has value, and this curious idea, therefore, is code a liability. And that doesn't mean it's a bad thing. It actually tells you why code quality matters. Interestingly enough, because any large company or any company at all manages liabilities as well as its assets. You don't just look at the good stuff. You look at the liabilities. You minimize the liabilities. You watch the liabilities like a hawk. You make sure that they don't run away with it, so that your code base or your company is brought down through its liabilities rather than being able to capitalize on its assets. So therefore, the idea is that, curiously, code is a sort of is in some senses, from that perspective, almost a necessary evil. This idea of it's the thing that allows you to get the functionality. And in order for it not to become a liability, you need to minimize it, understand it. And this is where testing fits in, is that testing provides you with this kind of surround of, this is the functionality that we want. The tests say, here is what we want to have happen. Here is what we believe should have happen. And there is code that fulfills this. And that actually moves your point of view around very differently. And it's an interesting thought experiment, but I don't recommend anybody go out and do this. But there's that idea of, if you had really good tests and you had really good code, and somebody said, we're gonna delete one. We're going to delete one of them, the tests or the production code, and they're both, let's just say they're really good, because otherwise you end up, people say, well, you know, actually it wouldn't be any loss if this were deleted in our company. But let's just assume these are both good. Which would be the greater loss? And it's a fascinating thought experiment, because it does lead you to the idea that, well, actually a set of really good unit tests that are really well formed and intentionally structured will show you the shape of what you want and how it should work and how it connects together, rather than the inside-out view, which is the classes and the individual functions. And so therefore the tests would ultimately have the greater value, because they describe the functionality and the relationships and the connection. So there's this I like these ideas, these alternative points of view, because they make you look at the thing that's currently sitting in your editor, or the thing that you normally value, from a very different point of view. And I still value code quality immensely, but it allows me to also justify, this is why our tests fit with it, this is why they are important, this is where actually the value lies. Where is the knowledge? And it turns out a great deal of knowledge is not in the code, it's in our heads. Well, we can't really keep those around forever. So perhaps maybe tests and other things, I'm not going to say it's just tests, but I'm going to say other things also help capture that.
I think that it's an interesting thought experiment. And the way I was thinking about that is, if you think you need both, and I do, then the question is, which one would you replace most easily? And the problem would be, suppose you had a working implementation and you said, okay, well, now we have to write a whole bunch of really good tests. And you don't have an incentive to do that. So, well, it works, right? But of course, if you had working tests, not only would you have to create the code, but you could do it very well. I think that I don't want to tip anything, because I don't think we've got a commitment yet. But Phil has been working with Michael Feathers to get him on the show, and Michael is the author of Working Effectively with Legacy Code, and in there he defines legacy code in this most amazing way, which when you first hear it, it's like, well, what does that have? That has nothing to do with legacy code, because you think of legacy code as, code written by other people or old code. I mean, there's all sorts of ways you can think about it. But his definition of legacy code is any code without unit tests. And at first it's like, well, what does that have to do with it? But I completely understand this, because this is one of the things, I used to work as a contractor, and I would go to project from project, and I would look at this code base, and I would know what I want to do with it, but I was always kind of terrified to go in and do it, because I wasn't certain that I understood how everything works. And I was just certain, I'm going to go in here and I'm going to break something and not realize I've broken it, because we don't have good test coverage. Because again, I came out of a culture of C++ where we didn't have good test coverage.
Yeah, there's a natural, it's a natural human response. There's a certain kind of
but when you have good
like,
test coverage, you are courageous, you are fearless. Because if you go in and break something, you'll know it before anybody else does. You can just run the test, and it'll tell you this function is used in a way that you didn't quite understand. And if you have that good test coverage, that's what keeps your code. That's the opposite of technical debt, right? That's investing in the future of your code.
Yeah, it's kind of you're buying an option to be able to change. That's effectively what you're doing. Now, there is an interesting thing. I just remembered that I do have an example. It's not a huge example of a case of where I did actually delete a whole load of code against some tests, and it's one that viewers and listeners may be more familiar with. Boost lexical cast. That we get to blame me for that one. And originally it was quite a small thing, but because it relies on IO streams, which are curiously, the less said about IO streams and regularity, perhaps the better. Because it relies on IO streams, there are lots of kind of weird cases that don't work the way you would expect them to. If somebody said, we're going to do this round trip conversion from this type to this type and then back again via a textual intermediary, as the name lexical suggests, but because it relies on IO streams, there's a little bit of quirkiness. Let's put it that way. And so I originally wrote that, and then we kind of added some things, and I handed over to a maintainer many years ago, and it was just before a release, and he sent me the latest code, and it was something like 500 lines, and it had more meta programming than you ever really want to see. And I remember thinking, like, no, this is too complex for the problem it's trying to solve. So I decided, okay, I'm going to try and refactor this code. I'm going to try and mess about with the indentation. Big mistake. At that point, it was so heavily indented that I basically lost the code. You could not see your way through all the meta ifs. You're sitting there going, like, no, this is too complex. So what I did is, I had written some tests for it. The maintainer had written some other tests, unaware of mine. I merged the tests, added more, went through all the cases that we were going to add, and made sure that the tests were bulletproof. His code worked. There was no problem with that. The problem is you couldn't tell why it worked, and certainly you would be uncomfortable changing it. So I captured the whole of all of the known issues and requests for the future in tests, and then deleted the code and built it up from scratch. And it went from 500 lines to 150, and with a much more light sprinkling of template meta stuff at the time. But that was an example of, I know with the functionality that I want. This is what people want. They're using this. They want it. They want it to behave in a particular way. So let's drive it from that point of view rather than from the implementation. And that actually turned out to be the way to save the code, was actually by capturing its behavior, kill the code, replace it with something that does the same thing. Wow. And I've seen teams do that on a larger scale, but for me, that was a very first-hand personal experience done in a relatively short time frame.
So I've seen someone attempting to do the opposite, and of course it ends in disaster, but there's a company I was contracting with had a very large application written in C++, and this was in the early internet days, not really early internet days, early web days. And so they decided that they're going to rewrite their application in Java. And they think, if we can keep the size of the Java app down to a certain thing, then people can download the app and run it in a browser. And it ended in complete failure because, of course, they couldn't possibly manage to put a Java app in as tight a code to make it work. But what constantly was the bane of their existence is they kept discovering new features that weren't documented anywhere. But what would happen is either the tester or someone else would come to them and say, well, this doesn't do this. And they said, what's that? They said, well, this. When you do this, it's supposed to do this. And I was like,
thing that it's always done that we never told anybody about.
Right. And I actually, there was a fellow that we hired from a company I'd worked with before, so I knew him really well. He was the new guy, and somehow he decided that he would work on a small part of the code which had grown basically by incremental pieces, and that was the graphics part. So this whole thing was kind of an analytical thing. You could tell it, oh, I want to build these graphs, and the way it had been done was, we added this and we added this, and after he was finished, he rewrote the entire graphics engine and made it rational instead of this incremental nonsense that had been there. And he was delighted because he kept bragging that his productivity for the 3 weeks that he worked on it was negative 50,000 lines or whatever it was. But one of the bugs that he had was it didn't do the correct thing when you did double overline. And the question is, what the heck is double overline? And it turns out that what they were trying to do is, if you think of an accounting document, you will do a double underline to indicate the end of a column. But the problem is, the way this software worked is you would do a query, essentially a database query, and it would list all the accounts that needed to be summed up. And so you never knew which was the bottom, because if it was 0, it wouldn't appear. So you didn't know which was the one that needed to be double underlined. It'd be the last one. And so the way that they did it was, they said, well, we'll take the total and we'll double overline it. But when he wrote the code, he had no clue what double overline meant, which essentially means, get the entire cell of the value and double overline the top of the cell. Instead, he did the opposite of underlining the number. He just put an overline over the number. But the point was just, it was completely undocumented. He had no idea what that was supposed to do. All he had was the name. And, and of course, the testers immediately caught it because they looked at the output of something that was done. But the entire application was functional. They made lots of money selling this application, but there was no test suites. It wasn't rigorously defined anywhere. And when they, as I said, tried to rewrite the whole thing in another language, it just failed miserably because they had no idea what the application actually did. In a formal sense. They didn't. There was culture there, so they saw the problems. The testers could see it. The people doing, they had internal people using the product to do templates kind of thing, and so they knew how it worked. There was a lot of cultural knowledge about how it worked, but it was never formally defined. And
I think that's this idea, again, going back to this thinking about tests from a different point of view. We were talking about BDD earlier. This idea of not just poking a product to, poking a piece of code, is it correct? That's actually not perhaps one of the more interesting questions at all. The most common question people have when they find code is, what does it do? Don't worry about if it does it well, but what does it do? What should it do? These are all the questions people have, and it's rarely, is it right? It's what is it supposed to do? What is it doing? How does this work? And which also gives this idea that tests are an exposition of here's what we believe it should do. We could be wrong in our beliefs, but at least if we try and articulate them and present them publicly, we're making them visible, and other people can go along and go, oh, I see what you mean there. That wasn't obvious to me, or that's not actually the right thing. Well, now I've made it visible. I'm playing a game with an open hand. You can see that. You can go, I see the misunderstanding that you have. And I find that's a really powerful way of thinking about it. I remember running a workshop many years ago. It was a week-long workshop. I got people developing sort of mini products. And one guy, I looked over his shoulder. I could see the names of his unit tests, the output. And I said, that's not quite what I meant. So I'm playing the role of the product owner here. And I said, that's not quite what I meant. And he said, so my tests are no good. And I said, no, your tests are so good. Just by looking at the names, I understood that you had misunderstood me. I didn't have to look at the body of your test code. I didn't have to look at your production code. I could just tell what your mental model was, and it was different. That's how visible it is. So this is an idea here of tests are an act of communication, not just one of confirmation. And I think that when we move over to that, then it also gives you a kind of a justification or a rationale for the ethos that we see that started me down the road of the LHR proof of concept, and Phil picked up and continued with Catch. It's this idea of expressiveness, offering somebody else a point of view. Here's a point of communication. Let me show you something. And maybe it's good, maybe it's not, but it's a lot more interesting than just it passed, it failed. I'm actually trying to describe something. I'm giving you a different point of view on the code or how I think about the code. And it's very powerful.
So I
We
used
have
to.
we have the term specification by example.
Yes,
well.
yeah, Goikohachi, yeah.
One thing to keep in mind, though, is not all tests are examples of specification by example.
No.
So sometimes you'll go to the test to see how the code should be used, and you'll see all the really awkward things that are trying to find the edge cases. And then people say, so that's how you're supposed to use it then. So one thing I try to encourage with Catch is to use the tagging system to say which types of tests are which ones you can go to see, is this sort of part of the executable documentation, and which is just trying to really stress test the API.
Yeah, I think that's a really good point about the problem is, again, you need an additional thing such as tagging to differentiate the landscape. Because if, for example, if I take an approach of writing, I take a sort of defect-driven testing approach, if I write tests whenever I have a bug, then I've got a nice piece of traceability. In other words, I've recreated the bug. This test fails because of the bug. Now I fix it, and now it passes. So that's a nice record of what we have learned. But it also captures that case. It's wonderfully traceable. But if somebody looked at all the tests that were bug fix tests, they would have a very odd idea of how to use the application. So it doesn't diminish the value of the test, but their purpose is slightly different.
I think that one of the things that I've discovered is that I would, when writing an interface, I would finish it and then say, oh, I guess I need to write some user documentation on how you would use this interface, and it almost always caused me to go back and change the interface, documenting it. And I wonder, does that happen when people are writing tests as well? Do you look at the test and say, oh my gosh, this is how we have to use this API? This is insane. Yeah. Because I understand what you're saying is that some of the tests, no, the test is written correctly and it is insane code, but we're trying to probe and trying to get at a corner case. And it's not the way we're recommending you write the code. But are there times when, as you write the code, you recognize, oh no, this API needs to be revisited? I'm recalling a story from Andy Hertzfeld, who worked on the original Mac team, and he was talking about Rose, Carol and Rose, who would come and ask them, because she was working on Inside Mac, which was going to document it, and she would come and ask questions, and Andy admitted, he said sometimes the answers changed, because when she asked the question, the first answer was, oh yeah, I guess the right thing is this, but by a week later it's like, no, this is how to do that now, because as programmers, we see through the code, we see the implementation, and so we think in terms of the implementation, and it makes perfect sense to us. Well, that's the way you would do it. How else would you do it? But when you've actually documented the functions and you try to explain the mental model, you'd say, well, nobody's going to figure out that that's how you would do it. They would do it this way instead, and that's when you realize, we need to either change the mental model or we need to change the implementation so that it follows it more closely.
Yeah, I think for me that is one of the
less a testing issue.
That's one of the values of
a documentation issue.
Well, I think that's the idea, is that as you're describing there, and I've had personal experience of this, sketching out something, thinking, oh, this is brilliant. Then I start writing, I write some tests, and I'm starting to think, wow, this is quite difficult to use. This is quite difficult, and I haven't really written anything yet, and it's already difficult to use. And so the ink is still wet. We can change it, and I think that it goes back to this idea of changing point of view, because often we're at the bottom of the well, looking out from the implementation up at things, whereas sometimes you want to sort of say, well, hang on, if I will ask that question, as you say, asking that question will change the answer, and it goes back to this idea of how do I use this, and this idea that the examples that drive it, as opposed to the examples of the edge case, but the examples that drive it are, I'm trying to make something easy to use. I'm trying to make something relatively intuitive, so it fits together as a whole. And how am I going to find that out? By the power of pure thought, by strong meditation, or by actually trying to use it? And a test is one of your early examples of usage. And so anything that causes people to question, either having somebody come along and say, what about this case, or you trying to write something against your own code, and a test is a really good example because you get something else from it as well. You're trying to use it and you kind of go, it's not as pleasant as I hoped, or I wonder if I could do it this way, this would be better. And again, it sort of intermingles these different activities, which I think is very healthy. You get to see it from more than one point of view.
We're starting to run out of time. There was one other topic that I had wanted to get into, but I think we'll have to leave it for another time. So
excellent. So there's a sequel set up here.
Can I tell you? Can I tell you one story then?
Can I ask a question of Martin first? We mentioned earlier about formal methods, and there was an indication that you've had some involvement with that. Is that correct?
Yes.
So that's something I had wanted to get into as sort of a complement to the idea of testing. But maybe we can have you on again to talk about that in a bit more depth.
Okay, that'll be fun.
Okay,
so we'll talk about that afterwards. So, John, you had a story to wrap up.
Well, I was just going to tell that I worked on a very large code base at a very large company that's very well known for its software, and it was very old. It had been released many, many times. It's a huge moneymaker for the company. And I used to tell people, I said, there's no bugs in this code base. And of course, anyone who was at all involved with the process realized that that was not at all true. But what I would say is, well, a bug is when the performance differs from the documented expected performance, or the expectation. And I said, the code is the documentation, and there is no difference between the documentation and the code. It does exactly what it is documented to do. Consequently, there are no bugs in this code. I think I was trying to make a point about the fact that we had no formal specification for the product at all. But anyway, we also had very poor tests. We had really, really good testers, but they weren't writing code. They were exercising the product, and they had it was, given what they were doing, it was amazing the quality of the level of the testing they were doing. But there was effectively very, very, very little automated testing going on. Most of the testing that was automated was simply scripts running automating what a user would do. There was, the idea of formal low-level tests were just wasn't. Just didn't do it. And it was all cultural. It was because, well, people didn't do that when the app was started, and now this was, release, whatever it was, 12 releases later, and we had just added a few little, token unit tests here and there. It's very sad.
Okay, so I guess we've got some great sequels set up here, haven't we? Formal methods, some really good stuff on the Slack channel discussing GC and other models. And John said he had a few things. I got a few things. So there's a lot of good sequels following up here, and we've only touched half of testing.
Well, you've only scratched the surface. I'm going to be doing a 2-day course on it at CPP.
Perfect. Yeah.
This is what happens with every episode. We always have about two follow-up episodes for every episode.
Oh, it's like a Hydra. You get cut on one episode, and two more heads pop up.
That's right. That's right.
At best.
So as Phil pointed out, we are a little pushing our time, so we need to wish everyone safe coding. Anyone have any last thoughts we need to share before we do so?
I think we should have a big thanks to the thunderstorm going on in the background on Martin's line. That had a bit of entertainment value. Probably won't come out on the podcast because I'll edit that out.
But just so you know, so hang on. At this point, we can take extreme liberties with what you might be editing out, and just say, we images of Martin just sort of underwater, and lightning in the background, and he was battling sea monsters and all kinds of stuff. When we say Hydra, we weren't just kidding. That that kind of stuff. Yeah, but that's all been edited out.
Yeah. Well, the video will still be online as well. So.
All right, so we're going to say goodbye by wishing everyone safe coding. So for everybody, until next time, safe coding.
Safe coding.
Safe coding.